That means JDK. JDK, and we need to install it in our system and set the class path and the home path up till the bin files. Once you download the jar files up till the JDK, you need to install it and then store the path up till bin and save the settings in your system. Once you save it, write the code either in the notepad or in the WordPad or in the Eclipse or in the NetBeans, wherever you want to write, you can write the code, right? After writing the code, if you want to compile it, please you need to write the command in the command prompt. Go to command prompt and open the CMD. Go to the folder where you have saved your file. Please remember, you should create your own folder for the file to be executed, right? After saving the file with the extension of .java, please remember where under which drive you have saved with which folder you have saved. Please specify the path in the CMD. Suppose if you are there on the desktop, your file is there on the desktop, change the drive to the desktop. Once you got it, please, in order to compile any Java file, we are going to give the javac space file name dot java. Suppose I have created a file name called add. Add.java is my command to compile the javac file, right? Once you compile, if there is no error, you'll get into the next link. Then you need to press java space file name in order to run the file. Then the output will be shown on the command prompt. This is the way you need to compile your Java code, right? Whatever the concepts you are learning in the data structures, those programs you are going to execute in the Java platform. Remember the steps: compiling and running and saving and writing everything. Okay, fine. Please look at the first topic in our syllabus. First unit is about the introduction of algorithm and mathematical foundation related to the topics, right? First, before going to the definition part and theory part about it, I just want to know from your side, what is meant by an algorithm? Don't read the comments which are there on the screen. Stop looking into it. Please tell in your own words, what do you mean by algorithm?
It is a procedure of to writing a program.
It is a procedure to write a program. I'll make it in a proper format, little bit furnished way. That's it. It is a finite step to accomplish a task. Am I right?
Yes, ma'am.
It is a finite steps to accomplish a task. The task might be anything. It's not only related to the coding. It might be any other task, like suppose you want to go to a movie. Now, what are the steps you will be doing first? First, you will be checking which movie you want to go and which theater at what time. All these procedures, step by step things are known as your algorithm. And it is a word from the Greek, ma. It is a two-letter word, algo and rhythm. Rhythm means a perfect procedure. Algo means always it should go correct, right? So from that analysis, it was picked up and it was written as finite number of steps to accomplish a task or to solve a problem. Before going to the other part or any other further discussion of algorithm, I just want to discuss certain properties related to the algorithm. What are those properties means? Finiteness, first property, not finiteness. First property is input. It may take input or may not. Please note down the points, ma. I'll be just opening it. Wait a minute. Are you able to see this blank one? No. I'll stop share this thing and I'll share the new one. Wait a second. Yes. Are you able to see the white screen now?
Yes, ma'am.
Yes, properties of algorithm. First, before going to the complete theory of it, I just want to give the properties first. First property is input. Whether it will take an input or not, but it will accomplish a task. In certain programs or problems or tasks, we don't require any input, but we'll get the output. Example, I just want to tell welcome to someone else. I may know them or may not know them. It is my function criteria. I should welcome them now. Output is welcoming them. Input is not giving, whether they know, whether not knowing them, and I'm asking them to come in. And one more example for this, to just print welcome statement. Did I give any input to it? Any input variable has been taken to it?
No, ma'am.
No. So input can be either 0 or more arguments. It's not 0 or more arguments I can take it. Right? Next property is output. Output must be at least one. At least one means one or more, 0 or more.
One or more.
One or more. It can sometimes it will give you more output depending upon the criteria which you are taking. So at least one output will be there. Then next step is finiteness. Finiteness means the number of steps, whatever you are performing to accomplish a task, they should be limited. It should not go into infinite loop. Okay? Finiteness. Effectiveness means what? Effectiveness means it should give correct result. If I follow that step, it should give me a correct result. That is what effectiveness. Suppose I just want to add two numbers and I have written the minus symbol. Will the output is correct for me? My task is to add two numbers, but I've written minus. Is the operation was correct? Is the effective step over here?
No, ma'am.
No. Such kind of things are known as your ineffective steps, but your algorithm should follow the effectiveness of it. That means your steps should be very clear. Clear in the sense they should be correct. The steps should be correct. Next, the last one is definiteness. Definiteness meaning what? Effectiveness and definiteness. Effectiveness means they should be correct. Definiteness means they should be clear. That means an ambiguity should not be there. Whether you want to subtract a minus b, b minus a, na, ambiguity should not be there. I want to subtract a minus b. If I write b minus a instead, will I retrieve the answer correctly? Sometimes
No.
I will get the negative answers, no? So your steps should be very clear. That means unambiguous. Unambiguous. They should be very clear. Okay. So what are the basic properties we are having under the algorithm? Input for any task. Certain tasks may not take any input. Output, finiteness means the number of steps should be limited. Effectiveness means it should perform accurately. That means the correct answer it should retrieve. Definiteness means it should be unambiguous. These are the basic properties of your algorithm. Before going that, you should have an analysis about it. And before going to the next step, that is, you need to have the thing like types of algorithm. No one will know what is this uh, types and all, but still you should know it. Types of algorithm. There are three types of algorithms, ma. First one is sequence. Second one is iteration. Third one is repetition. Iteration, repetition are one at the same. Control algorithm. Yes, ma. Please listen to this types of algorithms, ma. First one is sequence. Second one is iteration. Third one is control algorithm. That means sequence means without skipping any single step, we need to perform all the steps in it. Suppose if I take the process like preparing a tea, cup of tea for a particular number of persons, I'll follow the steps like keep the bowl on the stove, pour some water, add some tea powder, add some sugar, let it boil for some time, then add your milk, let it boil for some more time. Please switch off it and serve it to everyone. This is what sequence. I did not skip any step, nor I did not repeat any step, nor I am not depending upon the one step. One step is not controlling the other steps. Any condition is not there here. So this is such kind of situations comes under sequence algorithm. Certain situations will be there where the repetition is required. Iteration means repetition. Iteration means repetitions. You already know that we need we had iterative statements like while, do while, and for in your uh, languages, programming languages. Those statements only will come into the picture. In certain situations, some set of steps we need to repeat them. Like suppose I just want to print even numbers from 1 to 20. The calculation of your condition of your even number that divisible by 2. I need to repeatedly check that from 1 to 20. Here comes your iterations algorithm. Then the control statement. Suppose I just want to check only one single value, whether it is an even or odd, then the control algorithm will come. There I'll be specifying the conditional statements like if else, or switch, else if ladder, whatever it is, depending upon my requirement. So conditional statements will come into the picture. So depending upon the condition, it will execute either of the statements. So these are the types of your algorithms and these are the properties of algorithm. This is what the basic introduction to your algorithm. And algorithm means it is a finite number of steps to accomplish a task, or it is set of rules to perform a task. Whatever the way you want to define it, you can define it. Okay. This is what the brief review of it. Let me go into the complete view of your algorithms now. Are you able to see my screen? Yes, is it visible?
Yes, ma'am.
Before writing any code, you should be very clear in which programming language you want to execute. And moreover, what is your task first? How to get start of that task? And first you need to write your good algorithm, right? From that algorithm, we will be coming back to our coding perfectly, right? Please look at here. These are the properties which I have discussed just now. Here is an example for writing an algorithm. Please look at the steps. What is there? The first step. Usually we will be writing an algorithm with start and stop methods. First, start, declare the 3 integers, read the values, then add x and y and assign it to z. Then print z. What am I doing in this example? I'm just performing the addition of 2 numbers and storing it in the third number. Or else I'm writing an algorithm to add 2 numbers. Right? Yes or no?
Yes, ma'am.
Okay. Now, so are you comfortable with the properties and types and algorithm definition? Can I go with the performance analysis? Yes. Am I fast?
Yes, ma'am.
Am I fast, ma? Or can I go?
You can go, ma'am.
Okay, okay. Someone has raised their hand. Who is that? Yes, ma. Baru, why did you raise your hand?
మేడం మాకు 6th సెమ్ అని మెసేజ్ వచ్చింది. మీరు 5th సెమ్ చెప్తున్నారు కదా, అందుకోసమే రేజ్ చేసాం మేము.
అవునా, మరి నాకు మాత్రం ఇది చెప్పాలనే ఉందమ్మా.
ఇదే మేము డేటా స్ట్రక్చర్స్ మేము ఇప్పుడు మన 6th సెమ్ కి.
అవునా, నాకైతే ఇదే ఉంది, అందుకని నేను ఇదే క్లారిటీతో చెప్తున్నా.
ఫిఫ్త్ సెమ్లో మాకు డాటా స్ట్రక్చర్ ఎగ్జామ్ కూడా రాసాం మ్యామ్, అయిపోయింది మాకు.
అవునా?
సిక్స్త్ సెమ్లో మాకు వేరేది వచ్చింది.
బట్ నాకు చెప్పింది అయితే డేటా స్ట్రక్చర్స్ త్రూ జావా చెప్పమని చెప్పారమ్మా.
అవునా?
ఆ,
ఓకే
మరి
మ్యామ్
మేడం.
ప్రెసెంట్ 2019 బ్యాచ్ కి 6th సెమ్ కి డాటా స్ట్రక్చర్ విత్ జావానే ఉంది మ్యామ్ అందరికి.
ఓకే మా, థ్యాంక్స్ ఫర్ యువర్ సపోర్ట్. థ్యాంక్స్ మా, థ్యాంక్స్.
మరి న్యూ బ్యాచ్ ఎట్లా మేడం మాకు?
న్యూ బ్యాచా? You just ask with the one who is sharing the link for you.
ఓకే మేడం.
Get confirmed with them, no?
ఓకే మేడం.
Okay. Am I clear up till here? The introduction part of your algorithm, which is already known to you, but just I'm revising it. Can I go with the next part of it, analysis of algorithm?
ఎస్ మ్యామ్.
Yes,
Okay.
ma'am.
Before going to the analysis of algorithm, analysis means what? General meaning. I should get the answers from your side. Analysis means what? Any idea from your side?
To take the gist from one content
Hmm.
from total content, we'll take gist.
Okay. How it is performing, we'll get into an idea, right?
The examination.
Yes ma'am.
Examination, or by observing something, we'll let to know that whether it is doing its task or not. What it is doing, how it is doing. That is what the analysis. That is what the general meaning of an analysis, right? So here, performance analysis of algorithm or analysis of algorithm is one at the same. Sometimes the question may be given in such a way that write the analysis of algorithm or performance analysis of algorithm. You need to write the answer is one. That is the same answer for both of the things, right? Going into the depth of your analysis of algorithm, first we should write a good algorithm. That means it should satisfy all those 5 properties. Then we are going for the validating of an algorithm. Validating means whether we are retrieving the correct output for the correct input or not. That we need to verify. Then we are going into the analysis of algorithm, that how it is performing, step by step, what it is doing, how it is doing. That is what in-depth concept of ours, right? So before going to the analysis of algorithm, it in detail reads the 2 concepts, like how much memory it has been taken to accomplish the task and how much time it is taking to accomplish the task. Those 2 parameters comes into the picture. Those 2 parameters are space complexity and the time complexity, right? Space complexity and the time complexity. You need to remember these 2 points which comes under your analysis of algorithm. Validation means verifying whether you are getting the correct output for the accurate input. So performance evaluation means performance measurement will be done under 2 criteria. The one is based upon your space and time, right? Please look at the space complexity. Space complexity means what? How much space the program is taking to accomplish the task. That means while running, how much memory it is utilizing to accomplish your task. So obviously it will take a part of space occupied by the variables, static variables, and your arrays. So how many variables are there? That much amount of memory it in turn takes while the execution of your program, right?
Yes
So
ma'am.
here we need to take this particular formula. Please, I'll highlight it. Rest all the things is very simple for you. While reading, you will know it. Space complexity of any program one can be counted by the constant variables of that program plus variables. That means fixed variables will be there, no? Something like array, some fixed size will be there, like that. Some fixed variables followed with the space variables. That means the variable part, A, B, C variables are there, no? So those 2 combinations are known as your space complexity. In turn, I can shortly tell it as how many variables are there in the program. Those total memory count is your space complexity. Am I got it? So please look at this example. In this example, here is a float function. Return type is float and it is taking 3 variables as an input for your function. It is performing some mathematical calculation. Leave about that mathematical calculation. How many variables are there here?
3, ma'am.
3 variables.
So 3 variables space will be allotted to this particular function function 1, right? And result is also some return type, no? Result is also something it is returning. So even that also it will store. So how many variables it will be storing in total? 4 variable space of float type. So each one 4 into 4, that is 16 bytes of memory will be allotted for the function 1.
Ma'am, excuse me.
Okay.
In the float function, there are 3 variables, no? Including the return, it became 4.
That means your result, final result.
Okay, okay. Fine.
Okay. Can you go with another example? We'll just look at how many variables are there in this. You should tell me. Please don't look at the answer. Just take this example and let me know how much space will be. How many variables are there? First, let me know that one.
2 variables, ma'am.
No, more than 2.
3, ma'am.
More than 3. N is
It's
not
4,
fixed,
ma'am.
no, dear. N is not fixed over here. If n value is 3, then the array elements is of 3 elements. This is the 4th variable, n. Array size is your n. Here I am taking the loop for the I variable, no? Am I getting? How many number of elements of A is depending upon your n. So if I take my n value as 3, my array elements will be 3. And in order to store the result, yes, one more variable, that is 4. I variable 5 and n variable 6. Overall, those all combinations will be there in your sum. Are you getting my word? Indicates n, s, I and your a of I. Are you getting my words?
No, ma'am. Could you please repeat it once?
That's what I'm coming back. How many variables are there in this? Please let me know.
Normally, we are observing float, 1 variable, and integer 1 variable. In return, it will be 3 variables, and remaining we didn't get.
Can you please give me their names? We are having A is one array. Yes or no? This array size is not defined for us. But it is a variable of float type of array. Right? Remember A, then remember N. N is also a variable. Even it has some space to be stored, never task. Right? 2 variables followed with yes, 3. Right. I is 4. 3. Yes, already I have counted. 4. So how many variables are there? 4. But A is always depending upon the n value. That means the number of elements. Okay. So how many, if I take n value as 3, how many A values will be 3? Yes or no?
3, ma'am.
Yes, ma'am.
So n is, A is, array is depending upon the n. That indicates the size of your array elements. So obviously you are taking as, if n indicates the 3 values, 3, if n is saved with the, or n is assigned with 3, the A of I is repeating for 3 times. So how many variables are there in it? A of 3, n, s, I. Is that, or anything else was to be added? Is there anything else has to be added? Shall I covered everything? Yes, also I have used here. Return is only yes, not something else. Something result I am not returning. Whatever the calculated S was there, that I am returning. So I did not mention result over here. So what is the space required over here? A of n followed with n, s, I. Is that was clear for everyone? look at here, ma. A of n followed with nsi is the variables there in this particular function sum. So it extremely requires the memory bytes of your a of n followed with nsi number of bytes for this sum. Am I clear?
Yes, ma'am.
Okay, please. This is what determining how many variables are there in the function. Those many bytes of memory is required while executing that program, right? This is what your space complexity, counting the number of variables and enough. Coming back to your time complexity, which is very, very important. And time means amount of time taken by a program to complete the task. That means to give the output, whether the output may contain 0 or more inputs, but how much time it is taking to finish the task. So I'll just explain it with an example of table. Please take the same example which I have written on the top. Space complexity we have done, no? How many variables are there in that? 4. Yes or no? A of n, n, s, I. Yes or no? 4 variables unnaya?
Yes, ma'am.
Right. దానికి ఇప్పుడు టైం కాంప్లెక్సిటీ క్యాలిక్యులేట్ చేస్తున్నాం. Please look at the function first. That means whatever I have defined. Will the function definition will take any number of steps to be executed? No. Just declaration. అమ్మా అసైన్మెంట్ కానీ ఏదైనా ఫంక్షన్ రిజల్ట్ క్యాలిక్యులేషన్ కానీ ఏమన్నా ఉంటే దానికి టాస్క్ పర్ఫామ్ అవుతుంది కానీ డెఫినేషన్ కి కానీ డిక్లరేషన్ కి కానీ స్టెప్ తీసుకోదుమా. దట్ మీన్స్ ఎగ్జిక్యూషన్ స్టెప్ విల్ నాట్ టేక్ ఇట్. ఇట్ జస్ట్ go into the curly braces directly. So what is the step? First step, assign 0, 0 to yes. That is what your first step. Now tell me how many times this for loop is repeating from 0 to less than n, not equal to n. That means up till n it is repeating, no?
Yes,
And it is
ma'am.
taking the value from 0. So it will take how many number of times? N plus 1 times. Then how many this particular inner loop will be taking? అమ్మా ఇక్కడ కండిషన్ ఫాల్స్ అని చెక్ చేయడానికి ఒక స్టెప్ కావాలి కదా. సపోజ్ ఇఫ్ ఐ టేక్ n వాల్యూ యాజ్ 3, i ఈక్వల్ టు 0, it will evaluate. I equal to 1, 1 less than 3, condition is true, it will evaluate. I is equal to 2, 2 less than 3, condition is true, evaluated. Now I got incremented to 3, 3 less than 3, is the condition true?
No, ma'am.
But still it got repeated up till 3 plus 1 steps. That's the reason n plus 1 times it checks the condition. Then after, this inner statement always will execute n times, right? Then finally return result, return yes. Is it there in the for loop to repeat n times?
No, ma'am.
1 second, ma. Be on the line. Yes, ma. How many times this return s is repeating? Is it in the for loop? Is it there in the for loop or not? Yes, someone should respond. Yes, ma. Yes, ma. Am I audible?
Yes, ma'am.
Is return s is there under the for loop or not? I am asking. For loop
No,
లోపల
ma'am.
ఉందా అండి?
లేదు మ్యామ్.
కాబట్టి ఇది ఎన్నిసార్లు ఎగ్జిక్యూట్ అవుతుంది? ఒకసారి.
One time only.
Right. That is what I've written over here. First, initialization is one time, then followed with the loop. Condition checking always will be done by the increment of 1. That's the reason n plus 1 times. Then the loop will be repeated always with n times. If I start from 0, if I don't start it, it will be n minus 1 only. Then the result will be returned into 1 time. So overall, what is the summation of it? 3 plus 2n. 2n plus 3 is the time complexity of your algorithm sum. How much time it is taking? 2n plus 3. That means it depends upon your n value. Suppose your n value is just 2. 2 into 2, 4. 4 plus 3, 7. 7 seconds or 7 nanoseconds. Like that it will take. Okay? Did you understand with this time complexity now?
Yes, ma'am.
Yes, ma'am.
Time complexity means how much time it is taking to accomplish your task. That is what you need to remember over here. Right. Here we go with the recursion. Ma. You all know about the recursion concept. That means function calling itself. So at what situation it will be getting terminated means when the return of your function turned to 0, it will return it. If not, it will keep on executing it. Right? So please look at here. Here we'll take the two values of n equal to 0 and greater than 0. Suppose n equal to 0, what it will do? This recursive function, just it will return 0. Will it go to the else part? Less than or equal to ante return 0 అని అన్నా కదా. So it will be in the if condition and it will return only one statement. So what is that? It will execute the if condition and it will return 0. So how many number of steps it got executed for you? 2.
1 step. 2 steps.
Condition checking is 1 and return is 1. So 2 nanoseconds gani, 2 steps lo it got executed. If the condition is less than 0 or equal to 0. If n is equal to 0 or less than 0. Right? Suppose the problem comes in the terms like if it is greater than 0. If it is greater than 0 means obviously I'll enter into the if condition, sorry, else condition. Else what it is returning? Recursive sum of a comma n minus 1 plus a plus n. That means I am calling the recursive sum of again. How many times I'll keep on calling? Until I reach x plus 1. Right? So what is this? This is the first condition statement. I have to check this first condition. Then how many times it is getting repeated? N plus 1 times. N plus 1 times. That means function calling itself recursively because it depends upon the n. Getting my words? So it is n plus 1 or n plus x. Here it got placed as x. So you can write it as 1 plus n. So overall the time complexity of this particular recursive method is 1 plus 1 plus x. That is 2 plus n. Am I right? So this is what the recursive function call. Before going to the next step, try to analyze the time and space complexity of any algorithm depending upon the number of steps. Right? Am I clear? Can I go to the mathematical notation? Okay. Mathematical notations means asymptotic notations. Asymptotic notations will determine you the analysis like upper bound limit, lower bound limit, and within the range of your algorithm. That means maximum, how much time it is taking, minimum, how much time it is taking, within the range, how much time it is taking. That is what your asymptotic notations will be dealing. Most of the time, we'll concentrate upon the maximum limit value of your algorithm. That means upper bound of your algorithm. That's what we'll concentrate upon now. So please look into it detailedly. So asymptotic notations means it will give you the performance analysis of your algorithm. That is the time complexity we are going to analyze over here. And here we are having 3 cases, ma. Best case, worst case, average case. Best case means with the minimum number of time and with the minimum number of space, you are executing any task, then it is known as your best case. That means your input is minimum, your output is fetching very fast. Suppose I'll give you one example. I just want to find the minimum of 3 numbers and I've given the numbers randomly. Think like I've given them in the sorted order 2, 3, 4. I just want to calculate the minimum number. First number is the minimum number. So that was the best case, no? So in the first attempt only, I am getting the minimum number. This is what the best case. Worst case means it will take maximum number of steps and maximum amount of time or maximum number of iterations to accomplish the task, but you may find the output accurately or you may not. Your output will be given to you or you may not get the output. You may get the correct output or you may not get the output. This is what the worst case. The result, whatever the result you are expecting, you may get the result in certain situations, but in certain situations you may not get it. This is what the worst case. Average case means somewhere in the middle or at the end, your answer will be there. Somewhere in the middle or at the end. That means not to the worst of it, but you will be going to the maximum worst case you will be chosen over there. This is what the average case. So in order to show this analysis by this asymptotic notation, we are having 3 asymptotic notations, ma. Remember them very carefully. Depending upon the condition, we will be opting either of the notations, but we will be using mostly big O notations. Big O notation, theta and omega notations. And other 2 are there, little o notation and little omega notations. But we don't concentrate upon this 2, but we'll concentrate upon the first 3. And mostly we'll be representing by using big O notation only. Big O notations always determine the maximum upper limit of your time complexity. So please look at this big O notation. Suppose you have a function f of n, which is equal to the big O of g of n, if and only if there exists a constant and an n naught, such that means some variable n, such that it should satisfy the condition that your f of n should be always less than or equal to c into g of n. Your f of n will be always less than the c into g of n. That means you should have less than or equal to c into g of n. Such kind of function is known as your f of n will be known as your big O of g of n. Then your f of n will be known as your big O of g of n. Suppose f of n is 2n plus 3, g of n is 3n. Then if c is 1 and n naught is 3, you need to achieve this particular condition. F of n less than or equal to c into g of n. That means please substitute all the values and you will retrieve that always your f of n will be less than your g of n. That means 2n plus 3 always less than 3n only, no? Suppose if I take n value as 2, 2 into 2, 4 plus 7. If I take n value as 2, 2 into 3, 6. That means this is always less. Are you remembering this condition? Your f of n should be always less than or equal to c into g of n. Then f of n will be a big O of g of n. And always determine that it gives the maximum upper limit of your time complexity. Then please look at this following table. This is very, very important. Big O of 1 means constant. Log n means logarithmic. Big O of n linear. N log n means linear logarithmic, quadratic, cubic, exponential. These are the various computational times of your algorithms. Depending upon the complexities, either of the complexity will be chosen for your algorithm. And the relationship among them is like this. Big O of n will be less than big O of log n. Sorry, big O of 1 is less than big O of log n, less than log n log n, n square, n cube, 2 power n. So what is the highest time complexity? 2 power n. Exponential will be having maximum power when that. Theta notation means if f of n is equal to theta of g of n means you should obey the condition that c of c1 g of n less than f of n less than c2 g of n. So what is the condition? I'll write the condition over here, ma. I'm going to write the condition in the down. C1 g of n less than or equal to, sometimes it may be equal, f of n less than or equal to C2 into g of n. What is the meaning of this means? F of n will always lies in between the two constants of your C1 and C2. Within that range, your f of n will be existing in order to achieve the theta. Theta notation, I already told you that it will be not with the maximum or the minimum. Between the range, it will be showing you the time complexity. Between the ranges, it will be showing. So here is one example. F of n is 2n plus 3. The same one. C1 is one constant. C2 is another constant. Please substitute over here. It will be within the range. Then f of n will be a theta notation of your g of n. Some more examples are not there. That much examples are not required for you. Okay. Omega notation means it always gives you the lower bound limit of your time complexity. That means it always f of n will be greater than or equal to your g of n. C of g of n. C of g of n. Here C should come. C of g of n. If you multiply the C into g of n, it should be within that. At any value of your n, it should not violate that condition. Then only your f of n will be in the omega notation of your g of n. So what is big O notation? Always your f of n should be less than or equal to g of n. Theta notation, C1 g of n less than or equal to f of n less than or equal to C2 g of n. That means within the range of values, your f of n should there. That means maximum limit and the minimum limit should come into the picture. That is known as your theta notation. Omega notation means your f of n should be greater than or equal to C into g of n. That means it is retrieving you the minimum limit of your notation. Little omega, little o are there. This is about your performance analysis, ma. Are you clear with this notations? Mathematical representation, only this thing you need to remember. Yes. Yes, are you comfortable with this? Can I go with the next one? Next topic. Yes, ma.
Yes, ma'am.
Or shall I stop now? Can I take for 10 more minutes? Yes. The next topic.
Yes, ma'am.
Stack.
Okay, ma'am.
Stack is a linear data structure. What is meant by data structure means organizing a data in a format for our retrieving purpose or usage purpose. It depends upon the user which data structure you want to use it. Linear data structure were divided, actually data structure were divided into two types, linear and non-linear. Under linear, you have learned up till array. You are going to learn now list, stack, queue. These three concepts are there in your syllabus. So by looking into it, please look at the first topic, that is stack. Stack is a linear data structure. Stack is a linear data structure which will follow a property called LIFO, last in first out. last in, first out. Last in, first out means whatever you have inserted or whatever you have updated last, that will be viewed or resulted first. The best example I just want to give you is in your WhatsApp message, most of your friends will be giving you message. Suppose you did not see since 1 hour, your WhatsApp app was not opened by you since 1 hour. So what is the message? Which contact you will be viewing first? Which person you will be viewing first on the top? Is a person who sent you 1 hour back? Is a person who sent you just 2 minutes back?
2 minutes back.
2 minutes back. And in that, if you open the messages, suppose I have given you 10 text messages. Among them, did you find the last text message or the first text message?
First text message.
Fine. Here they have implemented this idea by using the two data structures. In order to display the contacts list who had given you the message recently, they have used the stack data structure. But in turn, in order to display the messages of the particular contact person, they have used the queue data structure. That is first in, first out. First message, what is there for you to be viewed, that will be viewed. Right? So topmost thing about it is last in, first out. What all the operations I can perform means push, pop, and display. In turn, I can perform is empty, is full also. Right? These are the operations what we can perform upon any stack. Right? Abstract means what, ma? Abstract means hiding the entire details, just retrieving how it is doing, but not retrieving the what it is doing. Right? Here are the some of the examples for that. ADT means abstract data type. That means it will give you the what all the operations it will be doing it. How it is doing, implementation part is different. How it is doing, it will not give it in the ADT. In the implementation part, it will be explained outside the function or outside the class. Sorry, outside the class, it will be explained. But within the ADT, what it is doing, it will just give you an idea. That means what are the list of operations, what is its behavior, what is the input it is taking. That is what your ADT, abstract data view of your data structure. That means implementation part is hidden in it. Right? So here is the definition of the stack. Stack contains a sequence of items inserted and removed according to the principle last in, first out, LIFO. Remember this. And some people mostly they will be telling like first in, last out also. Most of the people they don't even like they just want to rename it with some other name. So they have used it in the first in, last out. They are willing to call like that, but that does not perform over here. We are here to implement this last in, first out, right? So what is the variable on the top? We will be calling it as top, where the insertion, deletion operations will be done by this variable only, right? So this is what the stack ADT. That means we are going to perform all the operations like push, pop, display, is empty, is full, size. That means is empty means is the stack is empty. Is full means is the size is full. Size means how many number of elements are there. Push means adding an element into the stack. Pop means removing an element from the stack. Top means what is the topmost element. So this is what the basic operations just now I discussed over here. Okay. Push means inserting an item. Pop means removing an item. Top means retrieve the topmost element. Is empty means checking whether it doesn't have any elements or not. Is full means checking whether the stack is full or not. Size means returns the number of elements. Here is the example for it. Initially it was empty. Now I just want to push 1. Then after I pushed 3. What is there on the topmost element? Topmost element is what?
3.
Right. Suppose if I go for the operation pop, then what is the topmost element?
3.
Once I perform the pop operation, then what is the
1.
topmost? 1. Good. I'll just explain the stack using arrays implementation in Java in the tomorrow's class. I think today is time up. Do you have any other class right now, or shall I continue? Yes, ma. Shall I continue for 15 more minutes?
Tomorrow
Okay,
will
ma'am.
continue.
Tomorrow. Okay, ma'am. Thanks for your patience listening. Okay.
Thank you, ma'am.
You can leave from the class, ma'am.
Okay,
Thank-
ma'am.
Thank you, ma'am.
Okay, ma'am.